Hi, I'm David James from Team 3. My fellow teammates Dominic Cardelli and Christopher Moffat will be on shortly to discuss the instruments they built for this project. The instrument I'm going to talk about is a stringed instrument. It's one that I built for the project, which is right here. The biggest part of this instrument is this little block of wood right here that you can slide back and forth, which changes the frequencies on both sides. So I was able to tune in 8 notes for 4 strings. And that helped out immensely when playing the song "Ode to Joy," which is our team song. The design changes during the making of this was mostly to this block of wood here, which started off just a square wooden block, and I ended up rounding it off, putting a groove in it, and then adding this nail here that I cut the heads and the tip off of. It gives it a nicer sound, it's crisper. Then during the actual playing of the songs, I sounded a little bit dull on this side, so I added another nail down here to make another kind of bridge, which helped out a lot for the song. The physics behind this, I already knew what the frequencies I needed, and I knew what the lengths of the string were. The diameter I got off of the packaging for the string, and I found the linear density for nylon, which is the main component in fishing line, which is what this is, monofilament line, 50-pound test. So I used the equation, tension is equal to frequency squared times diameter squared times length squared times your linear density times pi. So that gives you the tension that you need to hit the certain frequencies for the sound that you're trying to tune for. The cost overall was under budget, as were all of our instruments for the team. But for mine specifically, it comes in at $11 approximately. You figured $1 for the block of wood, $3 for the base, $1 for paint. The line was $4. The 3 screws I use, I figured $1 for the 3 of them, and the 3 nails that I use, I figured $1 for the 3 of them also. So that comes in for $11. Well, during the course of this project, I learned about the physics behind the instruments. I was actually able to apply it to the string one, because that was the one that I actually prototyped and built. But I did learn about the wind and the percussion and the exercises, and it was very interesting. I actually enjoyed this course very much. The biggest inspiration that I got when I was doing the research, I found a video from a place called Bash the Trash. And he made what he called a tube tar. That's where I got the idea for the block in the middle, the sliding block he used on his instrument. He made his out of a tube, and I didn't want to use tubing because I didn't want to cut into the wind instrument's tubing length for the overall, or if the percussion was going to use tube or bars, I wasn't sure how they were going with that yet. So I just went with flat board and then made my design changes and added to it as I went along. That's pretty much about all I have for the stringed instrument. Now I'm going to pass it off to Dominic, who's going to talk about the percussion. Take it away, Dominic.
Hi everyone, my name is Dominic, and I designed a free-form type bar instrument that doesn't use any nodes, so the calculations for the frequencies are relatively easy. For instance, household objects like keys can be, let's see if you can see the keys there, yep. Keys can be thrown up in the air, and this is a high A, and what I actually did was I just hit it with a wrench, and it doesn't matter what object you hit these keys with, because I could even hit it with my fingernail while it's being thrown up in the air, and it'll still hit the same frequency. And environmental variables aren't a factor because it's the length of the object and the formulas provided in class that are actually determining what frequency output is being moved throughout the air there, through the airwaves, and through the sound waves throughout the air. And the other part of the design is to have objects such as glass jars that can be placed on a table and hit with an object, and they will also produce certain frequencies based upon the circumference and everything else, in the same type of formula that is used in calculating the steel. It's just a different type of material, so that that one part in the slide where it said 2,000 ms, 3,000, 4,000, 5,000, that's what's factored in there. And the cost is really cheap. It's just your everyday household materials that range from $1 to $3. The total cost of the project is around $12 for all of the different sounds that they want to make. And the design went from having things all put on a platform into just a free form, throw it up in the air, make it really exciting for the audience, give them a show in addition to the music that they'll be able to see, and a unique experience for them from that sense. And I learned some pretty cool things. As I was going throughout the design process, I was thinking, okay, well, how am I supposed to be able to do this? How can I do this? And it kind of occurred to me that I just started playing around with things and experimenting things and trying a bunch of different ways to try and make this work. And finally it occurred to me that I could just have a zero-node aspect of musical design, and it could be exciting to watch. And then it clicked, and I thought, well, can I use other types of materials? Yes, I can. I can use glass, I can use wood even, I can use anything, and anything can become a bar-type instrument as long as I calculate the frequencies correctly. And I could improve the design, I think, by having more, rather than just using household objects, maybe actually form something out of steel or form something out of glass. However, those expenses are kind of outside the scope of this class project, I think. And that's all I've got. Thanks for listening.
Hi, my name is Chris Moffett, and along with Dave Jenkins and Dominic Cardelli, we are Team 3. This is the conclusion of our presentation, and the song we played was Ode to Joy. It was split up into 4 different sections of frequency. My portion of the project was a wind instrument to play the mid-low section, and here it is. The design is simply PVC pipe material. This is 3/4 inch PVC, a coupler piece right here. Inside, to plug one in, is a wine cork, which happened to fit perfectly inside of the pipe. Got a nice paint job here. See how it sounds. Kind of nice. So the design of the flute, I've got 3/8 inch holes, and they are spaced out according to a frequency calculation, which is frequency set equal to the speed of sound in air over 4 times the length. So the speed of sound in air at a average temperature, because it does change with different temperature. Now, I didn't have a normal scale because the bottom note is an F sharp, and then it goes up a half step to a G. So I did do a standard fingering pattern. In order to get that G, I just lift off half of a cover here, and it goes a half step up to get that note that I want. Now, initially, my first design for the flute was a very small flute with a smaller bore diameter. I held it sideways like this, and it was very difficult to get a sound out. Bigger diameter, easier to push with the flow going this direction, was much better. Now, if I were to improve on this, I would learn how to properly carve this sound hole and the insides of these holes. That is where I believe my error in frequencies come from, or possibly the end. And I would also use better tools besides a hacksaw to cut things. Now, the cost of this is still very cheap. These can be mass-produced very cheaply. This is about $3 for the PVC material. I would estimate 75 cents for this wine cork, and then $1 for the paint job. So the one reference I did use was a library book called Musical Instrument Design by Bart Hopkins. It was very helpful in helping me get a general idea of flute making from old practices. So hope you guys like what we've done here, and hope you enjoy our song. Thank you.